Without further ado, I'm going to move on to our first speaker. And we're really fortunate today to have Professor Colin Moffat with us. I'm going to give a short biography of Colin, which he's not going to like, but I'm going to do it anyway. Colin's a visiting professor at Robert Gordon University and an honorary professor at Heriot-Watt University, and many of you will know him as he was previously Head of Science at Marine Scotland and responsible both for the Marine Laboratory in Aberdeen and the Freshwater Laboratory in Pitlochry. He retired from the post of Chief Scientific Advisor of Marine to the Scottish Government in 2021. Colin also led on the production of the OSPAR Quality Status Report 2010 and the Intermediate Assessment 2017, and has undertaken other assessments of the North East Atlantic and Scotland's Marine Assessment 2020. He was instrumental in laying some of the foundations for the UN Decade of Ocean Science for Sustainable Development, and is a member of the pool of experts for the UN World Ocean Assessments and a coordinating author of the World Ocean Assessment 3, due for publication in 2025. Colin continues to study contamination of aquatic systems by microplastics and pharmaceuticals, as well as the impacts of ocean acidification and climate change. He's currently a trustee of the Scottish Association of Marine Science, and I work with him very closely as chair of the Programme Advisory Group for ECOWind, which is a successive research programme of insight that's investigating the ecological effects of offshore wind. So without further ado, I'd like you to welcome Colin to the stage.
Good. Oh, I've got a wire. Oh. Good morning, everybody. And can I first of all thank the organisers for inviting me to come here this morning and to launch your conference. I'm absolutely fascinated by the subject that you've been studying. But what I want to do is I want to take you on a wee journey about some time ago, and maybe something about today. So I want to tell you a story, and all good stories start with once upon a time. And once upon a time, in an area of the North Sea that we were eventually going to call OSPAR Region 2, the Greater North Sea, an area that has a surface of 750,000 square kilometres and a volume of 94,000 cubic kilometres, so that's a lot of water. An area of water that's in a temperate latitude, strongly influenced by the waters that come in from the Atlantic, and characterised by actually a seabed that's mainly mud, sand and gravel. In other words, it doesn't have much going through the water column in terms of solid structures. An area of water that is home to some 10 million birds on an annual basis, that produces some yummy food to eat. Nephrops, really scrumptious. But also home to the likes of the ocean quahog, and this little beastie here, which could have been born when Shakespeare was writing A Midsummer Night's Dream, would have been sitting on the seabed back then, not with any clue what was about to happen to it. And it's also an area, I'm looking through the audience, and I'm not really sure how many of you would know. Have any of you guessed the year yet? No, okay. But probably not many of you were around then. I was, but I was in nappies. Okay, I don't know if any of you were more than in nappies, but anyway. It was the year that Crying in the Chapel by Elvis Presley was in the Hot 100. Radio 1 hadn't even been launched, so we hadn't had to listen to Tony Blackburn. The internal combustion engine ruled the road, despite the fact that in 1884, the first commercial production electric vehicle was made. But we made a choice to go for internal combustion engines. And also, diesel traction had not yet replaced steam traction in the railways up to Aberdeen. And actually, even in 2024, we still don't have electrification to Aberdeen. But also, when the atmospheric carbon dioxide concentration at Mauna Loa was 320.79 parts per million. And is that a lot, you say? Well, in the previous 800,000 years, the maximum had been about 285 parts per million. So more or less, since pre-industrial, 1850 to 1900, we'd gone from about 285 to 320. So that's setting the scene about once upon a time. But once upon a time, there was a discovery. And this discovery came about in 1965. Hope you all got that year. 1965, when gas was discovered off the coast of East Anglia. But it wasn't until 1975 that the first oil was brought ashore from initially the Argyll field and then ultimately the Forties field. And in that time, between 1965 and 1975, 10 years, the atmospheric carbon dioxide concentration at Mauna Loa had gone up to 329.38 parts per million. So it's going up a wee bitty. But Aberdeen became known as the oil capital of Europe. Great, thank you. And it was an oil and gas city. It transformed from a fisheries town to an oil and gas city. And over the next few years, indeed, up until 2015, when this industry reached its peak, when there was 173 active rigs drilling in the region, making this the world's most active offshore drilling region. And then in 2019, by the time we reached the pre-pandemic stage, there were only 112 active platforms. But what had happened over the period of time was that this massive infrastructure had developed of pipelines, of rigs, but also of coastal structures. And there were ships going back and forth at high frequency, and there were helicopters going back and forth at high frequency. And so ultimately, we had developed this massive industry. And at the same time, we put all these hard structures into what previously had been a water column and mud. By the time we got to the end of 2022, we've produced 46.9 billion barrels of oil equivalent. And what you see there is whether it's oil or whether it's gas, we have continued to produce it. And there's still quite a lot of reserves left. And also at the same time, we've got gas left. And in 2023, we produced 33.45 million tons of oil and 30 billion cubic meters of gas, worth something in the region of an awful lot of money. So that's where we're going. And so our story takes us to a time when we've produced a lot of oil. Now, if we jump back in time a wee bitty again, then we come to something called OSPAR Decision 98.3. And you're all going to be familiar with that. What's OSPAR Decision 98.3? Well, it's up there on the board, just in case you forgot. It's a decision on the disposal of disused offshore installations. And what it's basically saying is the dumping and leaving wholly or partly in place of disused offshore installations within the maritime area is prohibited. It's not going to happen. Brent Spar. Oh, did I mention that? What happened to Brent Spar? It was dumped, wasn't it, in deep water. But also it said, by way of derogation. In other words, there's ways around it. You don't have to if you can get derogation. So that was 98.3. Now, let's put this into context. 1998, OSPAR decides in July to ban the dumping of offshore structures. The OSPAR Convention came into force in, March 1998. So it was almost one of the first decisions that OSPAR made. Also, in terms of hazardous substances, there was a thing called background reference concentrations and ecotoxicological assessment criteria. They didn't last very long. What we use today came into force in 2008. Background assessment concentrations and environmental assessment criteria. And the other thing is, this decision was made before OSPAR had a biodiversity strategy. So actually, the decision was made where we didn't really understand too much about the biodiversity of the North Sea. But it's there. So what does this actually mean? Well, the challenge is that when this decision was made back in 1998, here in 2024, a lot has changed. There has been a massive change in something very specific. This, the carbon dioxide concentration in the atmosphere. And I've marked out 2 points prior to 2024. April 1998, so when the Sintra Agreement was made. April 2014, roundabout when InSight started. And today. And what do you see has happened? We've gone from 366.17 parts per million to, when this program started, 398.63 parts per million to 423.91 parts per million. And indeed, one of the daily averages recently, on the 29th of April, was 428.59 parts per million. Now, if you look at the difference between 1998 and 2024, in other words, when the agreement was made and today, we've got a change of 57.74 parts per million. So that's in about 26 years. Last time, that change took from 1800 to 1979. So that's a lot of years. So what that tells us is that since this agreement, the amount of change in carbon dioxide historically took 179 years. And we've managed to do it in 26. A big, massive change. And when you think about the fact that 100 parts per million carbon dioxide in the atmosphere, change of this amount, was the difference between it being a warm period and an ice age, and that maximum was 285, and now we're at 423, you begin to realize the severity of the differences that we are experiencing. And these differences come at a cost. The cost, of course, increasing temperature, deoxygenation, acidification. And these are just, if you like, the physical and chemical aspects. The biological aspects we are now beginning just to understand. To give you an example here, this is the daily sea surface temperature around the world, 60 south, 60 north. And what you see here is there's 2023 and there is 2024. Now this is obviously from 1982 to 2011 average. There's an awful lot there, so let's simplify this a wee bit here. Let's get rid of half of it. And let's look at 1998, 2014 again, and 2024. Now what you see is there's a lot of natural variation, because there's 99, 97, 98, but they're basically at the lower ends. Then we've got the 2014, 2013, 2015, and then 22, 23, 24. So what you see is, natural variation excluded, we are basically getting warmer and warmer and warmer. Now this is global. Let's look specifically at the North Sea. And this is the last 40 years ranking of sea surface temperature in the North Sea. And the darker the red it is, the higher it is. So look at our area here. Very, very dark red, the warmest in the last 40 years. And round about here, second warmest and third warmest in the last 40 years. So everything is showing that we've got a significant increase in temperature. It's not uniform around our northeast Atlantic, but look down here, Iberian Peninsula, Africa, we have got serious warming problems. And of course, where does our water come from? It comes south and goes north. There's another thing that's happened in the last 20 20 years, or since OSPAR came along. And that is that we've developed biological indicators. And this is taken from Quality Status Report 2023. And these are indicators of state, specifically for the Greater North Sea, of pH is pelagic habitats, BH, benthic habitats, FC fish, B birds, M mammals, FW food webs, and so an NI is non-invasive species. And what you see there is a summary. So we've got to the stage now of having multiple indicators of pelagic habitats, clearly of interest to us, benthic habitats, fish and fish populations, food web structures. We now have these. We didn't have these back in 1998. And the conclusion from this is that basically there's widespread degradation of the ecosystems. And actually, this is caused by human activities. Now, we're not saying what's causing it. We're not saying whether this is to do with hard structures in the North Sea. What we are saying, though, is that we can detect change. We can detect problems. We can detect 5 minutes to go. And it's okay. I don't have many slides left. So that's the problem. We can now detect change. What we aren't saying is why that change has specifically occurred. Oh, I've got 10 minutes, folks, so give me an extension for good behavior. Now, the other things that we've got is something about changes in plankton life forms. So we've got an indicator, again, of these changes in plankton life forms and what this actually means for our environment. And if we look at the holoplankton, then the results suggest, my gosh, we've got a bit of a change. When you look at the reasons for the change, there, that big splurge is because of temperature. So actually, we are now able to say that temperature, and in some cases acidification, is driving some of the changes in the plankton population. So actually, we are getting to the stage of beginning to say cause and effect. What this is ultimately saying, if you look at long-term trends, is that most planktonic life forms are declining in abundance throughout the Northeast Atlantic. Now, so far I haven't touched on, well, what's the consequence of having structures there as well. But what we need to think about is, if this is what is happening, and they think they know why it's happening, what does this mean for the science that you're doing? What does this mean for the interpretation of the science that you are doing? Now, of course, on comes offshore wind. Because the other thing was, back in 1998, how many people had thought about wind power? Well, actually, 15 miles away, or well, a bit more, 18 miles away from where I was born, there was a guy, James Blythe, in Marykirk, northeast of Scotland, who we think developed electricity from a wind turbine, the first person to do it. Which is quite useful, actually, because it was James Watt that's caused the problem we've got. And so, potentially, James Blythe has maybe solved it for us. But we made a choice. We made a choice to ignore James Blythe's work. And in fact, it was said by the locals to be the work of the devil, because he offered to actually power the whole of the community, streetlights, in Marykirk, northeast Scotland, in 1884. But we didn't go for it. Now, the other thing is that, what is this? This is the amount of, if you like, seabed, the spatial requirements for installations between now, 1990 and 2050. And this big blue bit is because of offshore wind. What we're saying is that offshore wind is going to actually require masses, oodles of space. far, far more than the offshore oil and gas industry required. And it's a global problem. And if you look at what we're seeing in terms of the development around the UK, this is significant. And although for offshore oil and gas, when we plot the oil fields, we get similar sort of spaces, the actual structures have a very small footprint. 5 minutes, it's 5 minutes this time. I don't get another extension. No, okay, right. But what you see is at the moment we've got 3,352 offshore turbines. The other thing is when are we going to replace offshore wind? Are we ever going to replace offshore wind? Because we're getting to a stage where we're saying offshore oil and gas, we're shifting out from that. We're stopping it. Is this permanent? Is this going to be our electricity source for the next 100, 200, 300 years? Rather than we've popped an industry in, we've taken all the stuff out, we're going to get rid of it. And what does that mean? If we get rid of all the oil and gas structures, we're just replacing them with something else. Whereas back in 1998, the concept was we take it away and it goes back to what it was originally. Well, that's never going to happen now, is it? Because we are putting in structures, and some of them might be floating and some of them might be fixed. So there's a big change today to where we were when decisions were made. I am just about finished, by the way. Now, already the offshore oil and gas, sorry, that's not offshore oil and gas, is it? The wind industry is thinking about, well, what can we actually do in terms of new development? We can build new ones, we can repower, or in fact, we can extend the life. Now, one of the important things that we should be doing is we should be saying that offshore wind is alternative energy. It is not clean energy. Please do nobody say offshore wind is clean. It's not. It is alternative. It has consequences. Because the flip side of the coin is, what you're saying is oil and gas is dirty. Well, actually, how dirty is carbon dioxide? How dirty is methane? The problem is not methane or carbon dioxide, it's us causing it to be emitted. So, now the conundrum. The conundrum is a program called Insight and the Insight Consensus. What you've all decided, thumbs up, is, and this is a quote by Professor Dickon Howell. From Tony. Our peer-reviewed science has revealed that these structures have positive as well as negative impacts on the marine environment, and their associated biodiversity is greater than anyone ever imagined. And you can see some of the other things that have come out. The choice of decommissioning options requires policymakers and managers to prioritize some targets over others, or when considering a holistic approach, to accept that some targets will likely not be met. 2 minutes, thank you. Some targets will likely not be met. Okay, how many targets have we actually met so far? Seriously, how many targets have we met? Why have we not been meeting targets? Is the science clear? I think it is. I think it's very clear. I think you've done quite an amazing job. So why are we not meeting targets? Why are we still having to debate strongly that we have an issue? Now, you'll recognize what I've got there, I hope. 1 minute, thank you. Do you know, what are these? These are the Insight main primary challenges, okay? So that's what you're here to do. A recent paper by Fortune, Majet et al., which they called Haven or Hell. Yes, Alethea's in the audience, by the way. Basically said there are problems. Not only are there problems, but we've got problems with data. We've got problems with criteria. We've got problems with protocols. I used to chair the Marine Science Coordination Committee for the United Kingdom, and what did we say? Oh, we've got problems with data. Oh, we've got problems with protocols. Oh, we've got problems with people doing things different ways. And in 2024, we're still there. Basically, we've got to think about improving the framing of policy. This is where we've got to go. We've got to think about net gain. Where's David Patterson? David, this summer, I believe. Yeah, David's going to sort net gain this summer. We've got relevant indicators of state. We know now. We've got them. We've got international agreements. But we are not being clear about what our government is thinking. What was the Scottish government thinking recently when it sort of said, let's forget about our targets? Well, they were never going to meet them anyway. So, here we go. What does success look like? We've got options here for what we might do. This is the Greater North Sea, the thing you saw earlier. Is that the solution? That when, and I'll flick back so you can see what happens, that we go green, basically. Is that what we're aiming for? And if we do that, does that mean that it assists us in determining management options and drives prioritization? We have the indicators, we know they're not green. Are we having to put them green in order to get our politicians to do what they say? And of course, we've just looked at one thing. Look at everything else we get from the ocean. Do we want to keep that or do we not want to keep that? So, this is my last slide. Ladies and gentlemen, what's the end of the story going to look like? It's up to you. You are going to decide. Now, yes, you're going to be nimble. You're going to respond to the changes that you're noting. But ultimately, you're the people with the knowledge, with the evidence, with the expertise. You need to get out there and get the people who are making the decisions to make the decisions. You're going to have to influence the people who go to OSPAR, or go to OSPAR yourself. You're going to have to go to ICES committees. You're going to have to go out there and speak to people and tell them using your evidence. Because my grandson is 2.5. He probably, hopefully, will be alive in 80 years' time. I don't want him to be looking out at a North Sea that is uninhabitable, that is full of non-invasive species, that doesn't give us fish. I want him to look out at a North Sea that has been looked after and that has been maintained because of you. Thank you very much.
Thank you, Colin, for a very rousing speech and for drawing together so many different threads across the last 20, 30 years. I think that was really, really interesting for us all and certainly makes you think. So thank you for